Today is trig integration, and for that, we need a bunch of ln natural log integration stuff. So, just a reminder, um, the integral of sine is negative cosine of x plus c, okay? And the integral of cosine x dx is equal to the sine of x plus c. All right, here's a few that we're going to investigate. So tangent, we're going to rewrite that as the integral of sine of x over cosine of x dx. And then we're going to make a u substitution. So I'm going to say that u is equal to the cosine of x. So du is equal to negative sine of x dx. So then dx isolated is du over negative sine of x. So let's make our substitution. So I have sine of x over u times du over negative sine of x. My signs cancel, giving me the integral of 1 over u du. So the integral of 1 over u is ln, the natural log of the absolute value of u plus c. And remember, u is cosine x. So this would be negative ln of the absolute value of cosine of x plus c. That's how we integrate tangent, okay? But you're not going to do that every time. Now, if you forget what the integral of tangent is, you're always welcome to derive it like this, okay? But I would make a Quizlet and start memorizing these. Okay, 4. So now let's derive cotangent of x. Same, but instead of sine over cosine, we have cosine of x over sine of x dx. Okay, making our u substitution. We're going to make our u equal to sine of x. So du is equal to cosine of x dx, and dx is equal to du over cosine of x. Okay, substitutions here. I have cosine of x over u times du over the cosine of x. And my cosine x's cancel, leaving me with the integral of 1 over u du. And the integral of 1 over u is the ln of the absolute value of u plus c. And my u was sine of x, so ln of the absolute value of sine of x plus c. Again, same thing. You can always derive the integral of cotangent, but I would start to memorize these. Okay, secant, another trig ratio that we haven't integrated before. So how can we rewrite secant? Okay, this one is not as straightforward. So I'm going to rewrite this as the secant of x times a form of 1. So secant x plus tangent x over secant x plus tangent x. I don't really expect you to come up with this, so I'm showing you how. Somebody, figured this out a long time ago. So anyway, I'm going to go ahead and distribute in my secant x into the numerator. So I get the integral of secant squared x plus secant x tangent x all over secant x plus tangent x dx. Okay. And next we need to choose our u. And I remember that the derivative of secant is secant tangent, and the derivative of tangent is secant squared. And I'm like, oh, secant tangent and secant squared. I'm going to make this bottom part equal to u. Okay. because when I take the derivative of that, I get the numerator. So the derivative of secant is secant tangent, secant x, tangent x, plus the derivative of tangent, go back the other way, is secant squared x. Okay? So, dx times the change in x. So dx is equal to du over secant x tangent x plus secant squared x. Oh, isn't that nice? All right, let's make some substitutions. We get secant squared x plus secant x tangent x over secant x plus tangent x. Oh, wait a second, that's my u. Plus u times du over secant x tangent x plus secant squared x. Ta-da! Cancel. Okay, so I get 1 over u du is equal to the ln of the absolute value of u, plus c. So replace out my u with secant x tangent x plus c. I don't like that. And that's that. That one's harder to remember how to derive. So again, you're probably just going to want to remember that one. All right, last one that we need to explore is cosecant. And again, it's very similar to how we would integrate secant. So I'm going to write this as cosecant x times a form of 1. This time I'm going to use cosecant x plus cotangent of x over cosecant of x plus cotangent of x dx. Distribute, and I get cosecant squared x plus cosecant x cotangent x all over cosecant x plus cotangent x dx. Make my u substitution. I'm going to try the denominator since it seems like we're really good at taking the integral of 1 over u. So let's see if we replace out the denominator with cosecant x cotangent x. And I remember I also used the pst to help me with cosecant and cotangent derivatives. I know that these are all c's and the middle one is negative. So I know that since secant and cosecant, I know that the first c belongs with secant, so that's cosecant and cotangent here. So the derivative of cosecant is negative cosecant cotangent. That's just how I use that. So I have du is equal to, okay, so the derivative of cosecant is negative cosecant x cotangent x, and then the derivative of cotangent, which would be that c, is negative cosecant squared. So minus cosecant squared x dx. All right, so du or dx is equal to du over negative cosecant x cotangent x minus cosecant squared x. And that's it. Okay, substitutions. I have cosecant squared x plus cosecant x cotangent x all over u times du over, and I'm going to take out this negative 1. So negative 1 times cosecant squared x plus cosecant x cotangent x. So I see that my numerator and denominator term cancel. And let's put these in parentheses. Okay, leaving me with my -1. So -1 times the integral of 1 over u du. So I get negative ln of the absolute value of u plus c, which is negative ln of, my u was cosecant x plus cotangent x plus c. And yep, that's it. Okay, just double checking. Making sure I wrote it down right. Okay, so again, not that easy to remember that one, so you probably want to memorize that. So the trig integrations that we have now are here, and I would definitely think about making a Quizlet at this point and start to memorize these integrals since there's a lot of them. Another place you can find a list of the integrals is on the inside cover of your book. Okay. All right, let's do some examples. So I got the first one is secant squared x, the integral of secant squared x over tangent x dx. And I just think about, like, if I took the derivative of something, like, will the derivative cancel with anything else? And so I'm going to make the bottom u, since again, we're really good at taking the integral of 1 over u. Okay, so if I have u is equal to tangent x dx, du is equal to, I use my pst, and then the derivative of tangent is secant squared. I have an extra dx here. Okay, secant squared dx, so du over secant squared x is equal to dx. And we make our substitutions now. So we get secant squared x over u times du over secant squared x. That's lovely. So I get 1 over the integral of 1 over u du is the ln of the absolute value of u plus c. And the ln, so this would give me the ln, natural log of the absolute value of tangent x plus c. Okay, number 2. Let's try this one. Okay, I have a root. I better write this as a rational exponent. So 1 plus tangent squared x, all raised to the 1/2 power dx. And I see a chain rule, so functions nested inside each other. So I need to do something. I use substitution at some point, okay? But, oh, I see something even better. 1 plus tangent squared x is a Pythagorean identity. Remember, 1 plus tangent squared x is equal to secant squared x. So I'm just going to replace 1 plus tangent squared x with secant squared x to the 1/2 dx, and the square root of secant squared x would be secant x dx, and then I know that the integral of secant is the ln of secant x plus tangent x plus c. So that one didn't, we used just a substitution so that we can solve a little easier. Okay, all right, next one. 2 more. Cosecant of 4x. So cosecant has a nested function of 4x, so I'm going to have to use a u substitution, okay, to undo that chain rule. So I'm going to go ahead and make the u equal to 4x, since that's the inside part of my function. So I have du is equal to 4 times dx, and dx is equal to, yes, du over 4, okay? So I end up with the cosecant of u times du over 4. And that is 1/4 times the cosecant of u du. The cosecant, the integral of cosecant is negative ln of, so I have 1/4 times negative ln times the absolute value of cosecant u plus cotangent u plus c. So the only thing I need to do now is replace in my u with 4x. So, and I'll just go ahead and multiply that with 1/4. So I have negative 1/4 times the ln of the absolute value of cosecant of 4x plus the cotangent of 4x plus c. Okay. And I'm just using my rules that I established for myself, like integral boundaries. There we go. Okay. All right. Let's do the last one. We're going to find an average value, because why not, of f of x is equal to tangent x on the interval from 0 to pi over 4. Okay. So I have an average value. I'm going to take 1 over pi over 4 minus 0. So minus 1 over the difference in the bounds times the integral from 0 to pi over 4 of tangent x dx. So 1 negative, I end up with, sorry, 1 over pi over 4 times the integral of tangent is negative ln of the absolute value of cosine. So negative ln of the absolute value of cosine of u, which is x in this case. And we're integrating from pi, wow. Okay, pi over 4 to 0. 0 to pi over 4, excuse me. Okay, I'm going to do a couple things. I'm going to multiply by 4 over pi to get my denominator cleared, and then I'm going to combine this with the negative 1. So I get negative 4 over pi times, and I'm going to plug in my bounds now. So the ln of the absolute value of cosine of pi over 4 minus the ln, the absolute value of the cosine of 0. Cosine 0 is 1. So I get negative 4 over pi. Cosine pi over 4 is root 2 over 2 times, okay, so negative 4 over pi times the ln of root 2 over 2. I can drop the absolute value sign since root 2 over 2 is already positive, minus the ln of 1. And the ln of 1 is equal to 0. So that whole thing is going to go to 0. So I get negative 4 pi times the ln of root 2 over 2. That's our average value. Okay, that's it.